theorem to, okay, this time I'll go a little bit faster. Okay, f dot dr for the function f. Okay, this is 2D also. Okay, 2D integrated round the square in the plane. Now this is z equals to 0 and bounded by the lines x equals to 0. Can you follow? Okay, I think you can copy also. Y equals to 0, x equals to a, y equals to a. Okay, this is the question. Since the question very clearly stated here is a Stokes theorem, okay, we need to use Stokes theorem, but is it they asking you to verify? No. Okay, but therefore you can use either one of this method. But let me show you both also very quickly, because I don't want to elaborate this into detail. But let us sketch this first. When we sketch, okay, okay, did they mention anything about the plane? Okay, whether, but we know there is a solenoid running, but they didn't mention anywhere, okay, it's anti-clockwise or clockwise. Therefore we can assume this is anti-clockwise first. If you get a negative as your answer, you change it to clockwise. Therefore the first part here, let's say is a 0, A, B, C. Okay, B here is a AA. Okay, and the line here is a A. I just quickly make it the solution for you, because okay, now done. Okay, now with this rectangle square, this square, let's start calculate f. Okay, the curl. Okay, when I calculate the curl, I, j, k, del to the del x, d to the dy, dz, z is x2 negative xy 0. Okay, and over here you get a yk. What is the message here? Okay, the rectangle actually responding to the y-axis. Y-axis, that means is actually if you start plot again the same logics here, z, okay, x, okay, y, okay, the things is upward. Okay, the circle could be anywhere, we don't care, but the things is upward. Okay, now let us proceed further. To calculate this, we use f del f curl f n to the ds. You can calculate this as a dx dy. We got an advantage here to calculate because this is a rectangle, oh sorry, square. Okay, this is square, therefore we can make it a little bit faster. Okay, then this is a to the 0, a to the 0, negative y dx dy. Wow, anybody can calculate? a3 to 2. Okay, then what about the fdr? F cycle dr. Is it 1 is enough? Yeah, because it's a 1 is enough, because we get a only k, only we can solve 1 only, no other options. Okay, here if we use similarly, we will get x2, the curve, dx, xy, dy. Therefore, the curve 1 by 1 you can calculate very fast. Okay, therefore, okay, if you pick 1 by 1 lah, okay, just when we can start doing this 1 by 1, step by step. The first steps that you will get here for the f dot dr curve calculations, the first one, then you need to go through 1 by 1. Okay, O, A, B, C, D. Actually, this one is talking about the overall, the loop actually reflecting what? O, A, B, C, right? And O back is a complete. Can you see that again? I show you O, A, B, C, O back. That means this is actually when we expecting this to calculate like this: O, A, B, C, O dot with the F, D, R. This is what actually we wanted to calculate. This means equals to OA, F, D, R. We need to calculate step by step, plus AB plus BC curve lah. We are talking about curve CO. Okay, CO. When you calculate 1 by 1, step by step, for example, and when we start calculate step by step, you will get something very interesting. Maybe I show one case, actually OA, for example, FDR. Okay, when you calculate O, then you get a OA. In this case, it's x2 dx, xy, dy, and therefore we get a 0 x2 dx a3 to 3. Okay, some of you may have a problem. You may say, sir, you're a bit fast, sir. Can you slow down a bit? Okay, just OA. Look at this OA. OA, y is a 0. What is the dy? Also 0. That means here y is a 0, dy also is a 0. Therefore, this is the things that you need to calculate. Can you calculate? Easy, right? Very fast. You managed to calculate. Okay. Similarly, okay, I'm not going to show everything, but just quickly lah. Okay, later I'll just write for the things, because there are a lot to teach, Okay, there are a lot to teach you. A, B, F dot dr. Okay, if it is a AB, x2 dx, xy, dy. Okay, okay, I get a A2 over 2. Okay, why AB is A2, AB. Look at this. AB, x is a dx is a 0. Dx is a 0. That means it's a dx is a 0. Yx is a then we know what is y, right? Can you calculate the y and dy? Yes, you can do that. Therefore, you get the answer. Similarly, you can calculate the BC, where you get a negative A3 over 3. Similarly, you can calculate CD, where you get a f dot dr equals to C0. Then you can calculate AC, also AC calculator already, right? AC FDR, you get a negative A3 over 2. That means in overall the Stokes can be verified. Okay? Can or not? Okay, can. A bit fast in this case, because I want to explain 2 more examples. Hopefully I can cover this both Okay, can okay, done. So far, not almost all the discussions are basically smooth surface. Let me pick one more example, which is this partial question also. Okay, example. One more example, 3. Is it 3? I don't know, maybe 1, 2, 3, 4 already. Okay, example 4. Let C be the positive oriented. I see they say positive oriented triangle lying in the plane 4 minus x minus 2y minus hopefully is a minus, yes. Okay, as shown, this means the problem is given as shown with pointing unit normal vector. Use Stokes theorem to find. That means is you no need to verify to find. They want you to find out this, where f is 3D AD. Z J X Y K. This is a 3D problem, and okay, which one they want you to start work? Okay, this is, we know by obvious, it's a tetrahedron. How do I know? Just to ask you, how do I know? The basic things is look at this plane. Look at this plane. From here, I can decide, okay, if x is y and 0, z is a, okay, 0, 0, 4. Okay, what about the here x? If a z is a 0 and y is a 0, x is a, okay, what you will get? 4 also, right? Therefore you will get 4, 0, 0. What about this one? Okay, if z is a 0, x is a 0, y equals to 2, 0, 2, 0. Okay. Okay, now the question, read the question properly first. Okay, read the question properly. Okay, hope that okay, let C be the positive oriented triangle lying. This triangle, you know, they're talking about. Don't worry about that, which whether is which direction at this first moment. We just wait and see first. You can assume, no problem. Shown with the pointing unit normal vector. Actually, is this one is, there is no shown here, but I assume this is where the things. But this is not a smooth surface anyway. They want you to calculate this. Okay, therefore you have a two choice. Maybe I call it A, B, C, D. That means you need to calculate this. Is it easy to work out these things? Because we know in order to calculate this, first of all, we need to we can use FDR. Of course, you can use FDR. I just let you know. You can use FDR and you call it C1, C2, C3. Okay, equals to, you can calculate C1. Okay, you calculate C2. You calculate C3. It's not easy because the line not anymore straight. I show you one case, but I'm not going to complete because I didn't calculate, because my interest is not to show this, because I wanted to show you how to use Stokes theorem to find this alone. Okay, it's alone. if you start using this, but they are interested on the surface. The question is actually, it's not, it's asking you, because you must imagine this problem is not talking about, it's not talking about three surfaces, other surfaces. You must imagine this is a one triangle like this, only one triangle lying only. Okay, don't imagine there is other surfaces exist. No, it's only one triangle lying on this. And how many surfaces are there? Two only. There are two surfaces only. Okay, A, B, C. Don't talk about D and all these surfaces not exist here. A, D, C is not there. D, B, C not there. Okay, it's not exist. Okay, they are saying that what they are trying to say, there is only one triangle. Okay, either the pointer is over there, and this is something kind of disc also, triangle disc. You must imagine triangle, okay, disc. It's a disc. Okay, it's a triangle disc. Therefore, when you calculate this, it's the same as the at the back. Okay, to calculate the surface of at the back. Okay, therefore, you see, you have this option. In order to calculate C1, for example, I'm saying, example is how to calculate this, the line here. This line, okay, C1 is not easy here. Okay, the line here, what is the equation for the C1? C1 equation of this is a x over 4 plus y over 2 equals to 1. Okay, then you make it to y, then this whole equation become x plus 2y equals to 4. This. Then similarly you can calculate the same way lah. Okay, I'm teaching you, I'm coaching you this. Okay, at this particular moment z is a 0. Okay, at this z is a 0. Okay, therefore our concern is k is not anymore, that means it's a dz is a, of course, 0. Okay, dz is a 0. Therefore you no need to calculate so much on the what you call z part. Okay, then okay, how to use the calculation of the c in this case here. Okay, here we know y dx plus z dy minus xy dz. Okay, to calculate the curve. Okay, since z is a 0, this one is 0, dz is a 0, we will have only this x y to dx. Okay, what is x here? X is a 0 to 4. That means it's a arrow looking at that. Okay, arrow, that support is a direction is moving up, moving towards, okay, this, whether it's a 0 to 4, okay, I use 0 to 4. Why? Why? Because you see the arrow is not moving outward but is going inside. Okay, now you can use dx or dy also. Here you can build the dy, no problem, but I want to make it a little bit faster. Therefore x, the representation of the x here is a 4 minus 2y. Then can I the y, you want to find the y, look a little bit, or you want to just change it, the dx also is a dx is a, okay, dx plus 2 dy equals to 0. Okay, then if you want to change the dx to this, you will get a negative. Okay, all you want to change it to the y, can also. Okay, but no problem lah, I'm just showing you here various way to handle the problem. Okay, in this case, let's say straight away, I'm not going to waste, I know it's easy. That means it's here. Y can be represented with this 4 minus x divided with the 2 is a y. That means it's a 0 to 4 minus x divided with the 2 dx. Okay, then you can solve the problem for the C1. This is how you can start and solving. I'm not going to solve. Okay, in this particular case, I'll just helping you to these things. My interest is now to, because I want to save some battery energy, therefore quickly I'll jump into the Stokes. Okay, this is how you should find C2 and C3. Then I hope that you can find out by yourself what is the solution for rest. And you add together, it's the same as this solution. Okay, as this solution, which is we wanted to, this is same as one single one, because we have only one surface behind. The surface for this, you will get shocked and surprised, because the question is look like that, but actually it's very clearly stated. It's lying one surface oriented triangle only. They are not talking about tetrahedron here. Okay, that means it's F times with the OO. F, okay, and ds, whereby this one is talking about triangle A, surface of ABC only. ABC only one. It's not talking about many surfaces here. Many surfaces open, only one surface, but at the behind. Okay, sometimes it's very hard to understand this part. Okay, the question seems not very clear. But don't worry, if you use this C1, C2, C3, you will get the same answer when you calculate for this one. Okay, for the surface of this side. Okay, let me start with this. Del F for the F part, ABC, behind. Okay, let us see, is it a behind or the whole thing? Let us check. Okay, when you calculate, because we know, remember, in this particular case the surface is not smooth. Okay, normal is not smooth, therefore you cannot simply say it's a K or what. Okay, we cannot conclude. Okay, now let us see, let us proceed. Okay, when I start using del to the times with the F, it's a I J K dx dy dz, okay, y z negative xy, which will give me negative x minus 1 I negative yj plus negative k. Okay, managed to. Okay, then del F is I plus 2j plus k. You agree? Okay, del F. How do I get del F? This is del F. Don't forget, del F is this. Okay, we need to, this is the F. You need to bring everything into one side. Okay, you get I to 2jk. Okay, sometimes some of you may say, sir, please could you help a little bit further? Okay, let me I show you this. I del yj plus del yz k. Okay, dot product with the, okay, because we're going to calculate on the F, right? Therefore I may say x plus 2y plus z minus 4. Okay, you carry this whole thing inside. Okay, you see the first one you get a I, 2 you get a 2, K you get a 1. Can you see that? This one is negative, therefore you don't need to worry about that. Okay, then del you get this, you got the logics here. Okay, what about the magnitude? Sorry, magnitude is 1 plus 2 plus 1 equals to 6. Okay, what about the n? N is del f to the del f. Here magnitude, you just calculate I to j plus k, you get the magnitude as a square root of 6. Okay, the next part is, where do we going to map this? Where do we going to map this? Okay, are we going to map to the k, or are we going to map to the, okay, the best I may say is z lah. Okay, put it on the ground of this, place on the ground. Okay, because I already told you, we only for this kind of square we can only use a shadow. We can use a shadow to solve it. Therefore I use a rho here is a k. Okay, ds as a dx dy and n dot rho. First question, why k? See, make it this is the, let's say this is the surface, make it I fold on this. When I fold, you can you imagine this is the normal. The normal also fold exactly at the same, therefore you get a k. Okay, normal can be anywhere, but when it fold on the surface, all become same. Okay, therefore you get a k, ds is xy. Okay, why are we using xy? Because this is xy. We want this whole triangle fall onto this floor, the plane xy, you see, xy. Therefore you will get dx dy and n to the rho, and when you use n to the rho, what do you get? See, rho is a negative k, n is this, you get a 1 over square root of 6. Okay, now you just substitute here. Can we just start work on the complete calculation here? FDR for the overall here. Wow, that you can start working on 4 to the 0, 2 to the x over 2, 0. I will explain to you this part later. What? Okay, we need to bring the whole what do you call f dot dr. Basically, okay, we're going to combine together. Okay, del f to the del f del x is n to this, matching with this, where you get a negative x plus 2y minus 2 dx 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 dy dx. The answer that you will get is negative 8. Okay, few questions, okay, which may confuse bit. Why dx dy is a, okay, remember when it fall on this, okay, how do I know the equation of this c here? Okay, the c, basically if it is a z is a 0, you look at this, okay, this part, if you are a bit not sure, here this one, okay, y dy dx is something like that. Okay, since we know, since z is a 0 at this portion, therefore the equation become, okay, the z x plus 2y plus x equals to 4. Z, yeah, z here. The z is a 0, you get the equation here, x to y 4, right? Therefore, I wanted to find out here dy. What is my dy? If 0, what is the dy? Y is equals to 4, okay, 4 minus x divided with the 2. Okay, therefore I get a 2 over x over 2. Can you get why we get this? Okay, I hope that you can follow. So far, any problem? Okay, what happened to this? Okay, of course, you see the logics here. You're not using this. Basically, you can see that f del f dot product times with the f, and ds is our, we already changed, dx, dy and rho. When we substitute this overall inside, okay, to the end, when we this end here, see, f curl times with the n, what do you get? Okay, what do you get? That definitely you get a negative x negative 1, okay, for the I, and positive y 2y, positive 2y, negative, you get a negative 2, not negative 1, negative 1. Okay, just you open the whole thing, you get a negative x, okay, plus 2y, okay, minus 2. Okay, can you see that? Okay, you got the logics why am I use this? Okay, in this particular case, this is how am I derived to this number. Some of you may be a bit curious to know what is this, where, doctor get it this, right? You may ask this question, doctor, I am not sure where did you get these results. Okay, actually the results is coming from here. Curl dot product with the normal, therefore you get this. Okay, done. One solution finish. Okay, successfully finished one portion. Okay, there is okay, I got one more question. I don't know whether the time will allow me, or the battery can allow, not time basically. We have ample time, but battery of my camera will, okay. I didn't realize this, I will record this level, this much in using, this is mine is a little bit old camera, that's the issue. Okay, no complaint anyway. Okay, just I would like to go through one more examples. Wow, too many examples, huh? But if camera finish, I won't be able to. Just you copy at least the line integral is evaluated as, okay, f dot dr for pi. The answer is given, for f 2x y I y z 2j. This is a little bit complex. Action on surface S, upper half of the sphere. X2, Y2, Z2 equals to 4, and C is counter clockwise, clockwise direction. Please copy first direction view from top as below. Okay, I'll show you. Use Stokes, just say Stokes theorem. Okay, Stokes theorem. F and ds. Okay, just quick sketch. Okay, half hemispherical. Okay, done. Okay, x, y. Top 0, 0, 4. This one 0, 0, 2, 0. This is 2, 0, 2, 0, 0. Okay, because how do I know it says 2, 0, 0 here? Look at this one. Okay, look at this one. How do I know the z is 0, x, y, z? Suppose it must be not a 4, it must be 2. Sorry, 2. Sorry, it's all because we use a one single radius, right? Okay, it will be 2, 2, 2, 2, 2 everywhere. Okay, hemispherical surface. Okay, can I make it a little bit faster to calculate? Okay, I don't think I won't be able to finish this solution because my battery is finished. Okay, thank you very much. I stop here.